Carbon dioxide is necessary for vital functions on Earth to be carried out. In the carbon cycle, carbon continuously cycles between the oceans, land, organisms, and the atmosphere, being utilized for various purposes. In nature, the decomposition of biomass, outgassing from the ocean, respiration of animals and humans, and naturally occurring wildfires, among other things, produce carbon dioxide. This carbon dioxide is then used in processes such as photosynthesis, ocean acidification, or is stored in living organisms to be utilized throughout their life cycles. Carbon is then reused, and the process repeats itself endlessly. But there's one big problem with carbon dioxide. We now have too much of it in the atmosphere. Why is this phenomenon becoming such a prominent issue now? Atmospheric carbon dioxide plays a vital role in regulating the planet's temperature, ensuring it maintains habitability for life on Earth. Think of carbon dioxide and other greenhouse gases in the atmosphere as a blanket around Earth, trapping heat on the planet to keep it from freezing over. But since the Industrial Revolution, carbon dioxide levels in the atmosphere have become out of balance, with more carbon dioxide being produced than can be regulated by natural processes. It also doesn't help that it's estimated that once carbon dioxide is added to the atmosphere, it has a life cycle of up to thousands of years. This is leading to an overall buildup of carbon dioxide in the atmosphere, increasing the amount of heat trapped on Earth. The resulting problems from this phenomenon have popularized the term climate change. This begs the question, where is all this carbon dioxide coming from? You might recall that carbon dioxide can be produced from decaying matter. Deceased organisms, such as plants and animals, are the main components of the fossil fuels natural gas, natural oil, and coal. In their raw forms, the carbon dioxide inside these fossil fuels is trapped, but upon combustion, the stored carbon dioxide is released into the atmosphere. Because the burning of fossil fuels became popular following the Industrial Revolution, scientists usually compare pre-industrial levels of atmospheric carbon dioxide to post-industrial levels in order to gauge how much of the carbon dioxide in the atmosphere can likely be attributed to human activity. The main source of direct carbon dioxide emissions is the transportation industry. In 2022, the burning of fossil fuels for cars, buses, and other vehicles made up 28% of direct carbon emissions, with electric power and industry following closely behind. The popularization of electric vehicles is meant to combat carbon emissions from the transportation industry, with countries such as the United States, China, and India, some of the world's largest greenhouse gas emitters, creating ambitious electric vehicle usage goals to help tackle emissions. Because carbon dioxide is also emitted with traditional energy production, a lot of initiatives to combat climate change also involve switching to more renewable sources of energy, such as solar or wind. As mentioned before, there are other gases in the atmosphere that are concerning. So why is there such a big focus on carbon dioxide in particular? Methane, for example, is estimated to be 80 times more potent than carbon dioxide, meaning it's 80 times better at trapping heat. But when compared to the sheer abundance of carbon dioxide in the atmosphere, methane is not as concerning. At least, not at the moment. To give you an idea of the scale of this issue, in 2021, methane levels in the atmosphere were measured at 1,895.7 parts per billion. Carbon dioxide levels in 2021, in comparison, were measured at around 414,700 parts per billion. Now, to measure the true impacts of methane comparatively to carbon dioxide, multiply 1,895.7 parts per billion by 80, and even then, methane's heat-trapping capacities are equivalent to 151,656 parts per billion. So even factoring in how much more potent methane is than carbon dioxide, because of carbon dioxide's sheer abundance in the atmosphere, methane's impacts represent less than half that of carbon dioxide. In fact, carbon dioxide is by far the most overrepresented greenhouse gas in the atmosphere. Of course, other excess gases in the atmosphere also pose an issue, but excess carbon dioxide by far contributes the most to climate change. Because it's such a prominent issue, a lot of countries are now focusing on reducing their carbon emissions. The Maldives, Canada, Finland, South Korea, and others all have laws in place to reach net zero emissions, which is balancing carbon emissions processes with carbon absorption processes, by a certain time. What solutions do you think could help reduce carbon emissions? Do you think they'll help? Let me know your thoughts in the comments.